Hey, what's up, students? I'm doing more of this coordinate point, slope, parallel, perpendicular stuff. This time I need to make a new equation in point slope form that is parallel and hits a new coordinate point. So here's the original equation. It's y minus 7 equals 2 times x plus 3. I need to make a brand new one of these that is parallel and hits 5 and negative 2. So remember, parallel means the exact same slope. So same m. So that means 2. There you are, 2. You're going to be my exact same slope. So m equals 2. And then I'm going to use the x and y coordinate points. 5 is the x, negative 2 is the y. All I need to do, students, is drop them into the point slope form, and it writes itself. So let's do that here. I'm going to rewrite y minus y1 equals slope times x minus x1. So y1 and x1 are basically saying the coordinate points, but y and x, the regular ones, stay in the equation. So here we go. Let's start dropping in values. Now, I like to think of it as just a quick switch. If it's minus y and the y value is already negative, you could write it like this. So y minus the negative 2. I'll just write it all out like a good math teacher would. Same slope would be 2, and then be x minus the y coordinate 5. Okay. Notice when you subtract the negative, it actually would turn into a plus. Okay, so in my mind, there's always kind of like a little switcheroo here. If it's negative 2y, the coordinate point, it's going to be plus 2 in the equation. If it's positive 5 as a coordinate point, it's going to be minus 5 in the equation. And that's it. I'm done. I just made a point slope equation. Oops, that's not very good. Take that back. I just made a point slope equation that is parallel and hits 5 and negative 2. I'm done. That's it. That's the answer right there. So I'm going to physically show you what I just did. All right, so here's the original equation. Y minus 7 equals 2 times x plus 3. So again, just to kind of hit home that idea of the oppositeness, if you see minus 7 and plus 3, you crisscross and make them opposite. This equation is going to hit negative 3 and 7. That's why it's called point slope form. There's kind of a point hiding in the equation. Okay, so the sooner you can say, oh, plus 3, it's going to hit negative 3. Minus 7, positive 7. If you can see that little switcheroo move, as you can see over here with the picture, that line is going to bullseye that corner point. That's what point slope form is good for. It's good for bullseyeing an exact coordinate point. Okay, so I'm going to copy and paste, okay, and now you see it's overlapped because it's the exact same equation. And now I'm going to take out the 7 and the 3 and put in the new coordinate point. So again, opposite. If it's positive 5, it should be a minus 5 right there. Ooh, it's getting closer. And if it's a negative 2 right here, it should be a plus 2 in the equation. Oops, that's not a plus 2. It's an equals 2. Plus 2. There it is. Bullseye right there. Look at that. 5 and negative 2 just got bullseyed by that brand new point slope equation. It's parallel, as you can see, because it has the same slope, but then it bullseyes a brand new coordinate point. All right, that's it. That's point slope form with a parallel line. Parallel slope means the exact same slope. All right, that's it. That's all I got, friends. Again, the big trick is the old switch. If it's negative 2 here, it's plus 2, positive 5, minus 5. And if it's the same slope, it's literally the exact same slope. Right, that's about it. See you in class.